All right, we've done those U substitutions, and now we are going to be doing U substitutions on different things. You've been doing U substitutions on things like this for a while now, log x. Did you know if you write with a backwards slant like this, that's like a sign of being a psycho killer? Anyway, so kind of squared, and then you go plus. No, I'm just teasing. Okay. Plus, now if you write with a forward-leaning slant like this, that there is a lot to handwriting analysis, and any of you guys actually had any experience in that? Like, have you taken any classes in that, or had a class that taught it? My daughter is just learning about it right now, so you can take a handwriting sample from somebody, and that doesn't mean you can like know all about them, but you can know stuff about them. You can learn stuff about them from it. All right, so I'm going to have this one equals -1. There we go. All right, this one's going to be a U substitution. You're going to have to notice, oh, it's something squared, something not squared. Even though it might look like this is squared, it's not, because that 2 can just jump down in front, and then you can do a U substitution and solve it. Please do that rapidly. You should be able to get the answer in less than 1 minute. If it doesn't factor, then you use quadratic formula, but this one does. Come on, focus. Okay, so here's what you should have thought. I'm going to let u equal log x. And I'm going to drop in the u right here. U squared plus this 2 comes down to the front, makes it 2u. And I'm going to add that 1 to the other side here. And now I'm going to factor it. It's going to go u plus 1 equals 0. And then these have to both be set equal to 0, but since they're identical, I'm just going to do one of them. U plus 1 equals 0, so u equals -1. Ooh, some of you might wrongly think, oh, it's a negative, and therefore I throw it out because you can't have negatives right here. But we're not done with the problem yet. We're not done with the problem. We got to do a substitution still. We got to let log x equal that. Log x, wherever I had a u, I'm going to put in a log x now. We made the problem easier for a while. Now we got to make the problem a little bit harder. But it's only being made harder at the very end, which means it's still pretty easy. So I got a base 10 here, so it's 10 to the -1 equals x. Raise your hand if you had that one right. Okay, good. That's right. It is the right answer. Okay, now there are other things that you can do U substitutions on, and I want to show you one like that. Everybody give this one a shot. 2e to the, let's see if you can figure out what I'm doing here, to the 2x plus 5e to the x minus 12. Do you see something squared and something not squared? Can you pull out something here and replace it with a u? Do a U substitution and solve it. Give it a shot. Wait, I have one last little tweak. Sorry. Make this a 12. Then it'll factor. Let me help you get unstumped. If I rewrite this as 2e to the x to the second, that might help. Do you get how that's the exact same thing as this? Because when I multiply it out, the x and the 2 will get multiplied and it'll be 2x. But it's better because it helps you to see that e to the x is my key. I'm going to have to do a U substitution and take out the e to the x right here and replace it with the u. Okay, so I'm going to take 2u squared plus 5u minus 12. And why is that good? Because it factors. And then later I will have to pay for that by making my u's back into, what did I have again? E to the x's. That's why I really should write it down. Let u equal e to the x. That way later when I'm trying to figure out what am I supposed to be swapping u for, I've got it written here. Now I think that's something you have to do on your calc test, because in calc they have certain rules on how you get every major problem where you have to show all your work in calc has like 7 points to it. 1 point is the answer. And along the way, this would be like one of the points you pick up. You're trying to build up points for yourself of showing your work. And because That's one of the reasons we keep pounding on you got to show your work, because when you get to these AP tests, they're graded by teachers. They're all trained on how they have to be graded, and they look for the work. It's not like a bubble test like you'd take, you know, for your ACT test or whatever. And if you don't show a step like that, you lose one of your points. And it's such an easy point to get. Next year, if you're in AP Calc, it is not graded Marzano style, and therefore you can't get 75% and get an A anymore. But there's more problems, and there's more easier problems too. You know what I mean? So tests have to be designed differently. Our tests, in theory, have 4 relatively easy questions and then 4 pretty hard questions. And then if you can answer 3 out of the 4 right, you get the A. In their class, it's going to be more your traditional 90, 80, 70, 60 kind of deal. But they do a lot of practice problems that are just like AP questions, and therefore you'll be given points for showing work. So where you're really going to have to be careful. Yeah, like even if you get the wrong answer at the end, you could get multiple points, as long as you didn't make your mistake really early in the problem. So anyway. All right. If you don't know how to factor well, this test will hurt you. I got to have 2u and a u. That'll make the 2u squared. And then the 12 is a 4 and a 3 or a 6 and a 2. You end up playing around with it. Let's say you figure out the 6 and the 2. You try the 6 here and the 2 here. And the numbers are so big, they're not going to be making a 5. It ends up being a 4 and a 3. And I think, if I remember right, the 4 goes here and the 3 goes here. And 4 times 2 makes 8, and 8 and 3 make a difference of 5. Now I just got to play with my negatives. Right, I just have to play with my negatives so that I get this to work right. 1 has to be negative, and if I make this one the negative one and this one the positive one, I'll have positive 8, and negative 3 makes positive 5. It's all about that middle term. All right, so then, final answer. 2u minus 3 equals 0, so 2u equals 3, so u equals 3 halves. But now we have to pay the piper. We made the problem easier, now we got to go back and make it harder. It's like Rumpelstiltskin has finally come back to get paid. Oh, it's a great analogy. See, he made their life better, and then he comes back, and then he wants their baby later. Yes?
Could you...
I can come back to you. All right. This other one over here, u plus 4 equals 0, and I'm going to go u equals negative 4. I got my 2 answers, but I now have to go back and do the substitution. It's not log. I substituted an e to the x for the u, so I got to go here and say e to the x equals 3 halves, e to the x equals 4. And now, this is really a key moment here. Oh, sorry, negative 4. This is a really key moment, and that's the key right there. When I rewrite this and I say ln, that's the same as log base e, of negative 4 equals x. What did I just do? I did a rewrite. It's so critical. You got to go this, that. Just be quiet, please. It's so critical. You have to be able to do the rewrites correctly. And now you might notice, wait a minute, you can't have a negative right there, can you? And therefore, yeah, it's in the argument. Yes, good point. And therefore, we cross it off and say that's an extraneous answer. This one, let's see if it comes out and plays nice. We go log base e, it'd be just fine, same as ln, and then we jump over to the other side, 3 halves, e equals x. And is there any reason to think that that would be negative? No, it wouldn't be negative. There's no negatives in it. So I'm not going to worry about whether or not it crashes my function. Now, it's kind of hard to know if it really works, though, unless I actually stick it in. Wherever I see the x, I'd have to put log base e of 3 halves. Pain in the butt to check on that one, I have to admit. So anyway, I probably wouldn't have been checking that one myself. I would have probably said, that's my answer. Calculators are not allowed, so you can't really even know if that's like 5.73 or what it is, but that's my answer. As long as this is not an e of any sort. If that had been an e, then all of a sudden maybe we could make this thing cancel. Like, say it had been this, log base e of 1 over e. That you're supposed to be able to do. Negative 1. Good. All right. Some other just quick notes. This, I'm writing slanty backwards again. Is that the same as that? No, big difference. This one I can put that 2 down in front. That one I cannot. This one's just all set up to do u substitution on. Okay? And you remember sine and cosine when we did those squared? Remember this? That's where we put the squared. We don't do that on logs. If you're going to square something, you put it up here. All right? Then this little 2 can go to the front, or you can put it up to the top. When would you ever want to put it up to the top? If you were trying to make them cancel. Let's say I had this. Let's say I had that. If I wanted to cancel my logs right now, I could. I could cancel my logs. If I wanted to cancel my logs right now, I could not. Do you get the difference? Right now I can't cancel them because this one is not a plain log base 10. It's got a 2 in the front. I got to know what to do with that. Let's look at the difference. If I cancel them here, I'm saying that 2x equals 16, and therefore x would equal 8. Do you get that that would be totally different than if I said this and canceled it this way, and I'd say x squared equals 16, x would not be 8, would it? All right, so only one of those two can be right. So we have to cancel it when it's in this way. We cannot have a 2 out in front. Another example. Let's say I want to do a rewrite. 2 log base x of 5 equals 12. Can I rewrite this as is? No, I cannot. How can I fix it so I could rewrite it? Put the 2 up here. Now I can rewrite it and say x to the 12th, oopsie, equals 5 squared, 25. And then how would I finish? I'd put it to the 1/12th power. All right. Now this one would be this would be a really nasty one because everybody would go like this. Okay, 1/12th, 1/12th, x equals 25 to the 1/12th. What's wrong with that? Plus or minus. Why? Because you did an even root. Trying to warn you about all those little things that can get you, the small details. Okay, so absolute value is equal to that, and therefore x equals positive and negative 25 to the 1/12th power. Would I expect you to know this part? Nope. Would I expect you to remember that? Yup. All right, so there's a lot of stuff to know. Any even roots? Yes. You know the reason why? Because square roots that have negatives under them are impossible unless you use imaginary numbers. And that's why when you do a square root, you got to be careful that your number has to be the absolute value of it because you can't have a negative. So what it really boils down to is if you ever do this to both sides, do a square root on both sides, you got to have the absolute value thing because you might have an issue with negatives. But why not with cubes? Because if I have like -8 underneath here and I'm doing a cube root of it, it's not a big deal. It's okay to have a negative there. And therefore, I don't need it to be the absolute value. Okay? So it's only when you're doing roots, like this is a square root. Any kind of even root, those numbers are even, you got to have absolute values. Okay. I think I've done enough practice with you. There's a ton of rewriting on this. Let me just do one more thing. How'd you rewrite that? Log base of equals, and you keep asking yourself, the goal here is not to get the e alone. I've had a lot of people goof that up on problems that have an e in it. They're like solving for e. E is a decimal. It's 2.718. It's get the x alone. So I'm going to divide by 2 here, divide by 2, and I'm done. And now, what if I was asked to put that in the calculator? Log 15 over log 10 is the top, and then, it's divided by 2. Or you could do times by 0.5, or you could put a 1/2 out in front of it. 1/2 of log 15 over log 10.